Hi everyone, and welcome to EarthEcho Snack Size Science. My name is Jacqueline, and we're here to talk about water, both fresh and salt. There are a lot of people online right now, so I do want to say that if we experience any technical issues, it's simply because of all those people accessing the internet. Also, a recording of this video will be available right here on our YouTube channel, so you can always come back and check it if you need to. So let's get started with today's Snack Size Science, Don't Be Salty. First, let's go over materials, which is what you'll need. So you will need a clear jar or glass, a large bowl, table salt, plastic wrap or a beeswax wrap, a small rock, a towel, because sometimes science can get messy. And if you remember our pro tip from Miss Stacy and Vivi Rose, I also have a puppy pad down to protect my table from any spills today. So our Earth is a water planet, 97% water actually. And you may remember from our water quality snack size science that Susan shared with us that all of the water on planet Earth, only 3% of it is fresh water. However, of that 3%, only 1% of total water resources on Earth are available as fresh drinking water. So as you can see in this photo, if we took all of the Earth's water into one marble, it would be that bigger marble that you see there with the oceans included. Then if we took the fresh water that's in our lakes and rivers, it would become an even smaller marble. But if we took just what we are able to drink, so what's available for drinking water, it would be in all of the fresh water. It'd be in that even tinier blue marble that is hard to see there. So that gives you a good visual of what our planet would look like. And you can see there in the photo that our planet is a lot of water. All that brown you see there would be water. So all of that water, both fresh and salt, goes through something called the water cycle. And you may have heard of it before. And if you have, that's great. This will be a little refresher for you. And this is the process when water evaporates from the surface of the Earth. You can see there in our diagram. It rises up into our atmosphere. It then cools and condenses. It can make clouds. And then it falls back to the surface of the Earth again as precipitation, such as rain or snow. And then the whole thing happens again. So again, it's a cycle. It's happening all the time. So how many of you out there watching, have you ever tried to catch a raindrop, or maybe if you're up north, a snowflake on your tongue? What does it taste like? Any guesses? I'll hold a second. Is it salty? Is it fresh? Oh, that's right. It's fresh water. So when precipitation, that's kind of a hard word to say, precipitation, such as rain or snow, comes down from the sky, it has already been evaporated from the ocean, but it doesn't have any salt in it. The Earth naturally desalinates the water. So in the water cycle, you can see again, that water, the salt comes out of the water. So when we have precipitation, rain and snow, there's no salt in that. It's just fresh water. So desalinate is kind of a big word. What does it mean? Have you ever heard of salinity? We've talked about it before with snack size science. Salinity, quite simply put, is the amount of salt in the water. So if you think of the ocean, which is salt water, it has a very high salinity. And when you think about the water that comes out of your tap, do you think it has a high salinity? No, it has a salinity of 0 or no salt because it's fresh water. So first step in our little demonstration today of Don't Be Salty is we're going to make our own salt water. So I'm going to take my clear jar. I took out a step just because I'm in my office, not my kitchen at home. So I added the water to my jar already. And what I'm going to do is I'm going to take the table salt that I have also collected. It's in another glass jar here. And so we'll take this table salt, and for this demonstration, guys, we're not getting super scientific in terms of measuring. So there's not a specific amount of water or salt, so don't get caught up on that. It's just fun today. So we're gonna take the salt water and we'll mix it in, or the salt, excuse me, we'll mix it into our jar of water. And we'll just kind of give it a little swirl. And that's why we put our puppy dad down, because we spill a little. And you'll see that the water, we've made salt water. It's now cloudy. Everybody see that there? So we're gonna give a second for that salt to do its thing and dissolve in the water there. And I want to go back to why we're calling this session today, Don't Be Salty. With such little fresh water on our planet, in the form of liquid, specifically drinking water, it's really important for us to make sure that we have enough fresh water for everyone. It also allows us sometimes to be creative when it comes to how we provide that drinking water. So remember, only very specialized plants and animals and some other organisms can drink or ingest salt water, but humans like us, we can't. It would make us very sick. So that's where something called desalination comes into play. When water is desalinated, it means that the salt is taken out. Also some other minerals and stuff too, but mostly the salt is what we're talking about. So desalination is, it can be a lot of different, can done in different ways. So there's different processes that allow water to be desalinated. But at the end of the day, all of those processes take the minerals and the salts out of the water in order to make the fresh water suitable either for animal or human consumption or for irrigation, so watering our crops. So today we're going to make a solar desalination plant model, but how? So let's set up our simple demonstration to see. So what we'll first need is our large bowl. So we have a large glass bowl here. You will also need our newly made saltwater mixture. You will also need a smaller glass jar or bowl. I'm using a glass jar from my baby because he has baby food and it just worked, so I grabbed that. And then you also need either plastic wrap or a beeswax wrap and a rock. So let's take, and I also just want to say real quickly that we're going to be setting up this demonstration today, but depending where you are in the world, and actually anywhere you are, this demonstration takes some time for it to do its thing, to see the results. So we're going to set it up. I left mine out for 6 hours, so I'll show you that in a little bit. We'll do a little bit of a reveal. But let's go ahead and set this up. Then you'll kind of just set it to the side, and then when we're done today, you can go ahead and take it outside. So first thing we're going to do is take the salt water that we made earlier, and we're going to pour it in our large bowl. Now remember, we're not being super scientific here in terms of measurements, but you want about 2 inches, if you guys can see that there, about 2 inches approximately of the bowl with salt water. All right. So now we're going to take the clean drinking glass. You may have glass. Again, I have a little glass baby food jar. It works. And we are going to put that in the center of the bowl. So we're just going to set it in the bowl. Now you want to make sure it is not submerged under the water. Okay, so I'm going to move to the other camera real quick. My friend Casey is helping me out here with the camera so you can see it's not submerged in the water. We'll put it back under the dot cam here. And why do we need that glass in the middle? Does anyone have any guesses? I'm going to pause for a second and see if anyone has any guesses on YouTube. We put this empty glass in the middle of our other jar, sitting in the salt water. All right, so we put that glass there because it is our collection cup, basically. So it's going to collect the fresh water that we're going to desalinate or make. All right, so now to our next step. So we have our salt water in our glass bowl. We have the smaller glass jar bowl cup inside that. As a house, we try not to use a lot of single-use plastic. So I actually didn't have any plastic wrap, and I didn't really want to go get it. So I did this experiment with a beeswax wrap. So it works out okay, but there's a little bit of a trick with that. And that is that the beeswax wrap doesn't super tightly seal like plastic wrap does. So what I found is I take a little bit of Vaseline, and I'm going to just kind of coat the edges here of my glass bowl. You want to make sure you go all the way around. And if you're using plastic wrap, you can skip this step. But if you're using a beeswax wrap, this is a really important step. So we got our Vaseline there. Going to take the beeswax wrap and pull it over pretty tightly. And then I'm just going to push down those edges. So again, with plastic wrap, you know, it'll pretty much stick up to your glass right away. With the beeswax, I'm going to do a little bit extra pressing just to make sure that that seal is complete with the Vaseline.
And Jacqueline, this is Casey here, and we're monitoring our chat on YouTube. And we do have some observations and questions that I just wanted to call out. First of all, we want to possibly revisit that slide that we showed earlier about the fresh water and the available fresh drinking water on our planet. Jenna out there on YouTube asked if this slide is indeed to scale. How accurate is this slide? Can you speak to that a little bit?
So this slide is something that I borrowed from our friends at USGS, and NASA uses this one as well. This is more of a visual tool for us to think about all of our planet, and if we were to condense it into something that we could picture. Does that make sense? So it's not necessarily to scale, but the marbles are in scale to each other in terms of how much water is available.
So it's a proportional illustration.
That's a great way to put it. Thank you, Casey.
Perfect. And then also, Jenna out there on YouTube asks, we're going to go back to that empty little cup that you put inside the bowl. And she just wants to double check as she's doing this alongside you that there is no water in that cup, correct?
Great. Yes. Great question. Yep. Empty glass jar.
Okay, perfect. And then her prediction is that the water will collect in there.
I love that. All right. Great prediction, Jenna. So let's go back to setting up. Great. I appreciate that. Clarifying is always really good. So yes, the jar in the middle of my setup over here does not have any water in it. And that's why I said you don't want to submerge it either. It's totally dry. So we'll go back to our setup real quick and making sure everything is sealed. The next part is we're going to take a rock. I have a special rock I wanted to show. My good friend Katie likes to paint rocks. So I have my little mola rock here. It's pretty. And I'm going to place it right in the middle of my beeswax wrap. Okay. And you want it to be directly over the glass. So while I show that on the big camera, make sure I have everything lined up there. Does anyone have any guesses as to why we want that set up right above the empty glass? And why do we want the beeswax or the wrap to kind of go down? Why do we need the rock? Are there any guesses out there for those of you following along? Good. Yes. So what the rock does is it acts as a weight, adds just a little bit of a dip to your wrap over your glass bowl, and that's going to help us collecting our water. So that is it for the setup of your desalination little solar demonstration that we have here. And so what you would want to do is take this outside and put it in the sun. It is really important that you put it in direct sunlight. So find a spot that has a lot of sun for lots of hours. And like I said earlier, depending on where you are in the world, you may have to leave this out a little bit longer to get the desired effect that we want to see. Since we're in Florida and it's pretty hot here right now, I was able to leave mine outside for 6 hours and see some results. I could probably leave it out for longer and get some more fresh water, right? So let's go back and think about the water cycle really quick. I just said when you take this outside, it's really important to put this in the sun, directly in the sun. Why do you think we need to put it in the sun? What is the sun going to provide for our little desalination model? That's right, heat. That's what the sun does. It heats things up. So when the sun provides heat, it is going to allow the water in our bowl to evaporate. So when evaporation happens, it's going to go up. But since we have that wrap there, it's going to get trapped by the wrap. Then we have the rock, which is putting it down. So as the evaporation happens, the water is going to condense on your wrap. And as it condenses on your wrap, it'll then start dripping down into your empty glass. To review, desalination is several processes, but the main point of desalination is we remove salt and other minerals from water in order to obtain fresh water that's suitable for us to drink or to use to water our crops. in some places of the world, they're really subject to drought, and fresh water can be a problem. So finding available fresh water, having it for people to drink, watering our crops, it can be an issue. So some places in the world, desalination is a vital process that helps them provide that drinking water for communities. Again, today we made a solar desalination plant. And I was wondering if you guys would like to see what happened after I left my desalination model outside for 6 hours. So I feel like a little bit like I'm on a cooking show here. So we'll pull out our freshly done desalination model. I'm gonna put it over under my dot cam here. Got a little bit creative. You see I used a marble for this one. So you can really use anything for this. So we're gonna peel this back. And first I'll show it up close. It's a little bit hard to see in this camera, but you can see there's still some of that salt water existing on the outside. But let's take out this glass that was once empty, and I'll hold it up to our front camera. And what do we have there? Fresh water. So I have collected fresh water out of salt water. So that took 6 hours, like I said, in my backyard in the sun. So why? You can actually take this demonstration a little bit further. You could try leaving your model out in different times of the day. You know, I thought, what would happen if I left this out at night? We're losing the sun. Would we get anything? I don't know. It might be fun to experiment with that and play with it. Or for times, maybe you leave it out for a 24-hour period with sun and night and see what kind of fresh water you can get from your desalination model. The other thing that we have with EarthEcho is we do have a design activity that challenges you to create your own desalination plant. So I would encourage you to check that out if you're curious about seeing maybe about how larger scale desalination works. You can also learn more about freshwater resources, including a real live video or a video with a real live desalination plant at www.earthecho.org with our expedition Water by Design. I would like to encourage everybody to, actually, before I wrap up, let's see if there's any questions out there. Casey, do we have any questions on YouTube?
Yes. So first of all, we have a lot of really great reactions to how your experiment ended. So that's pretty exciting that I love the cooking show, and everybody else did too. They were surprised that you did get fresh water. So that's super exciting. So we do have some questions coming in. Just, I think, for clarification, so that everybody understands when they set up their own desalination demonstration. So one of the questions coming in was about that weight, that rock, or that marble. So to clarify, it's not there to hold down the wrap, but rather it's there so that the water drips down into that empty cup that you put in the middle, correct?
Yeah, exactly. So you don't have to worry about, oops, the wrong side of the wrap. Okay. You don't have to worry about the wrap staying on. For example, with the beeswax, that's why I did the Vaseline edge. If you're using just plastic wrap, it's going to cling to your glass bowl and it's not going to go anywhere. So you don't have to worry about, the rock or the marble or shell, whatever you want to use, is not to hold the wrap on. It's simply to make like a little indent. So I'm gonna hold this. Yeah, here we go. So it just creates just almost a little bit of a slight incline. So underneath, I'm gonna go to the big camera here. Let's see, my beeswax wraps are, well, there we go. So you can see that it's dripping down right into that glass jar. Perfect. So as the evaporation happens, the fresh water droplets will get stuck on the inside of the wrap here. They'll condense up there. And then because we have that rock or marble, the droplets will kind of make their way naturally, and then gravity works, falls right into your empty cup.
Awesome. So one question we have coming in from Vivi Rose, joining us from Charleston, is could you do this with other heat sources, like maybe over a fire? Or does the heat have to come from the top, say the sun?
I think that is a great question, and it's not really one that I've thought of before. I know that some large-scale desalination plants do use different ways of actually providing the heat to cause the evaporation to happen. not sure if this would work if, if the heat came from the bottom. I think it might, but I think that that would be a fun one to try. So Vivi, I encourage you with an adult supervision to try that one and see if you provide heat from the bottom, maybe not necessarily the sun, if that works.
And to kind of go along the lines of going further with your experiment, Jenna had a great suggestion of taking this a little bit further and trying to set up 2 desalination models and try it on different sides of your house to see how the sun hits your home in different ways.
I love that. And I think that's a great observation, Jenna. And I think that would be a really great kind of experiment to take this, model, this demonstration into an experiment. I noticed that the first time I tried to set mine up, I put it outside and it started thunderstorming. So that didn't work too well. But then the next day I tried and I thought I had it in a really great sunny spot. But as the sun moved through the sky during the day, the trees in my yard made a shadow. And so I thought, well, I don't think that's the most effective 6 hours. So then I tried it again and found a more clear spot that got sun longer. But I think that would be a fun way to take it a little bit further as well. Love that.
Excellent. And that looks like that wraps up our questions from YouTube. Lots of good comments.
Great. Thanks, everybody. I appreciate the support and the enthusiasm. And if you do this demonstration, please let us know your results. You can let us know on social, send us an email. We would love to hear from you and see how you take it further or what you find with it. I also would like to encourage everybody to tune in again on this Friday for Snack Size Science at noon. It's called Defend Your Drain, and we'll be looking at microbeads and microplastics. And I'm really excited to say that we have one of our very own expedition fellows hosting that one. So it'll be really nice to have another face joining us for Snack Size Science. Also, please be sure to subscribe to our YouTube channel, so EarthEcho's YouTube channel. You can catch all of our virtual programming that way. And our mission is to inspire young people to act now for a sustainable future. So we encourage everybody to support our mission by donating if you are able to. Thank you so much for stopping by for some Snack Size Science today. I hope you had fun and learned something along the way. From all of us at EarthEcho International, stay safe, healthy, and keep exploring. Bye, everyone.